The next shape that we're looking at here is a pyramid. So notice that we have two different types of pyramids shown here though. Pyramids can have different bases. So the bases that we see here are a rectangle on the left, and the base on the right is a triangle. Now it's different than our formulas for prisms because notice there's not a parallel base. So because we don't have that parallel base feature, it's not just base times height like we've seen so far. Instead, because of this pointed action at the top, if it comes together in that way, we also are going to take 1/3. So we're going to take 1/3, and then the formula is still the same of capital B times H, where B is the base area. So our capital B here either indicates our rectangular piece or our triangular piece for this example. And again, you can have any side length for our pyramid here. It could be one with a base of a hexagon, which is a six-sided shape. You can have something that has a decagon on the bottom. So you can have unlimited sides on that bottom piece, but it's still going to follow the same formula. It's just going to be more complicated to get the area of that base. But if we look further and first click on the base of that rectangular prism, you'll see that when we break that down, because we're going back to base of the rectangle, the area of this base is length times width. So that capital B is length times width. H is going to be the height that makes it three-dimensional. So these pieces stay the same. And then 1/3 stays the same as well. A little bit different, if we look at what happened when we had a triangular base, it becomes a little bit more complicated. Because it's the same formula, capital B is a little bit different. Capital B in this case, for our triangular, is going to equal 1/2 base times height. Now again, we talked about how the triangular prism had that little bit of complication because H is used twice. But so imagine that. 1/3 times 1/2. That's where this 1/6 is coming from. And then if I go further with it, this is actually B and H. So that's the B and the H that replace those L's. But the height runs here. So that height is what sticks that piece together. So in this particular triangle, we have something like this. Now, because it's always going to vary, I wouldn't worry about so much about writing out a formula each time for a base as I would know how to plug into the formula. So what I would do first is always calculate exactly what that base area is and then plug it back into the volume formula. So we just want to remember, always never forget about capital B and that it's got its own formula as well.